Welcome everyone. I guess we're going to get started, and as always the first part whenever you do a lecture series, if you've got a cell phone in your pocket, turn it off, either turn it off, turn it down, or turn it to happy. And depending on who you are, vibrate could be happy. You won't say whether or not. Welcome to it. This is the 2013 CCOVI lecture series. My name is Kevin Kerr. I'm a professional affiliate here as well as an instructor and part-time researcher, and basically soup to nuts, whatever's left over, they asked me to help out with. Today I get the opportunity to introduce Dr. Tony Shaw. Tony is a CCOVI fellow, and he's a professor here in geography at Brock University. He's got an honors bachelor degree in geography from Wilfrid Laurier University, as well as his MA and PhD in geography from the University of Western Ontario. I've known Tony for a number of years. He's been involved. A few of the things here are climatology and its influence on grape production in Canada, applied climatology and meteorology, vineyard site selection, climate change, and building climatological networks. As well, Tony was heavily involved with the development of the sub-appellations within the Niagara region for the Wine Council of Ontario and VQA. He's been extremely interested in the wine business for many, many years, as all of us, and he brings a unique perspective because he's looking at it from the climatologist perspective versus the plant biology of others. So with that, Tony's talk today is going to be on climate change, opportunities and risks for Ontario's established and emerging wine regions. Tony.
Thank you. First of all, I'd like to welcome our live audience and also the folks who are watching on the webcast. Thank you for tuning in. It's a great pleasure to be here once again to present another lecture on climate change. And also, I'd like to say that it is a very interesting, very intriguing area. Not in terms of academic research, we've gone beyond academic, as this is a very serious business. So my talk today, essentially what I'd like to do is, first of all, look at the established wine regions of Ontario, the three principal regions, and also some of the emerging areas in Ontario, and look at what's happening to the climate over the last 40 years, looking at the empirical data. And also, we're doing some work on climate projection using a general circulation model to look at what is likely to happen in the next 30, 40 years as the climate continues to evolve, not only in Ontario, but for that matter throughout the world, in view of human-induced changes associated with the burning of fossil fuels and so on and so forth. So, this is just a map of Canada showing the areas where we have established wine production. Those of you who are in geography, you may be familiar with this. As you can see, we skip across the prairie regions, and the reason that area is not suitable at this point in time for grape production because not so much the summer, but the winters are very extreme. And then as we skip into Ontario, you'll see that wine production has evolved over the last 150 years around the Great Lakes area, but not all over the Great Lakes, but only in the preferred areas of Great Lakes, in fact, areas often referred to as the Snowbelt region. And then as we go a little bit east into Quebec, Quebec is what we might call a fledgling industry. We do have wine production there, not a huge area, but it's also evolving, and in fact that area is seeing some significant changes in climate, especially a moderation of winter temperatures. And then as we go further east into Nova Scotia, the province of Nova Scotia, in the Annapolis area, that is the area where we're seeing significant increase in wine production, especially white wines and sparkling wine. This area has actually garnered a number of awards for some of the wines produced here. And I might add also in Prince Edward Island, surprisingly, they are not only just noted for production of potatoes, but that area is also seen as an area likely to emerge in the next 20 to 30 years in terms of wine production. The Niagara region, of course, in Ontario, Geographically, these are the established areas. Those of you who are familiar with these areas here, of course, the Niagara region is the biggest area, followed by Lake Erie North Shore, and of course, Prince Edward County. Those are the established areas. At one time, Pelee Island used to be considered one of the wine regions, but it's no longer. It's still considered a major viticulture area, but not an official wine region, certainly according to the VQA. And then we have these emerging areas. Norfolk County has already made a reputation by producing some very good wines. And this area has about 6 wineries, commercial wineries. Not a huge area under production at this point, but this is one area I suspect in about 4 or 5 years will emerge as the 4th wine region in Ontario. And then we have considerable interest in growing grapes in Huron County, and for good enough reasons, because Lake Huron has a significant moderating influence on the climate of the eastern shore here. This area, of course, is right in the snow belt, so winters can be, in this case, not necessarily cold, but lots of snow. And as you'll see later on, with climate change, we're seeing more and more open water, and so there's potential for greater moderation of extreme temperatures coming from the north. And then we have the Grey County, Georgian Bay area. This area, as you know, is quite famous, both in the summer for recreational activities and certainly in the winter for skiing. That area, I am quite certain in about 10-15 years already, we're seeing some vineyards there and a few wineries. But with climate change, quite possibly these areas will emerge as significant areas. And then at this point in time, very limited planting in Durham County. Now, Durham County, of course, has been in years ago a very big tobacco area. So the soils there, very mixed soil, ranging from, in some cases, heavy clay to a relatively light sandy loam soil. Very significant variation in the topography, a very scenic area, and that area has shown some interest at this point. There are a few vineyards and I think 1 winery, but potentially this area, from a marketing standpoint, is location in a very close to a very rich and very big population. And of course, as you know, cottage country is just to the north there, so this area is actually very advantageously located from the standpoint of agrotourism. So those are the emerging areas, and what I've done in the analysis is to look at how these areas have emerged over the last 40 years and looking at the information on a seasonal basis, just to start off with. Now, I don't think there's any skeptics in the audience here or out there, or many skeptics regarding climate change. I would think by now that we've gone beyond trying to debate whether the climate is changing and whether that change is attributed to what we call human activities. I think hopefully we've gone beyond that. But I just want to show beyond the Lake Ontario, St. Lawrence, Great Lakes Basin that in fact the climate is changing in Canada. And that change, of course, is triggered primarily by an increase in carbon dioxide and various greenhouse gases. And so I've chosen this particular site here, Allard, on the very northern tip of Ellesmere Island, because when we monitor climate evidence for climate change, and we look at some of these very important gases, in this case are carbon dioxide, we want to go to remote areas and actually measure what we call background concentrations. And as you can see, beginning from 1975, you can see then there's been a steady increase in CO2 level in the northern part of Canada. Now, to the point where the current levels is 390 parts per million by volume, which is quite significant. The first set of measurements, of course, were done back in 1958 in Mauna Loa, Hawaii. And since then, of course, we've had a number of stations monitoring carbon dioxide levels throughout the world. In Canada, of course, we have a few of these stations. These stations, of course, are not established in the populated areas for various reasons, because you have unusually high concentrations of CO2. So you need to have remote locations. So this particular island here is the number one site, a very important site monitored and managed by Environment Canada and the World Meteorological Organization. So this is a very important site, and as you can see, there's very clear evidence in terms of the buildup of CO2 levels. And very quickly, we've seen an analysis by regions for Canada. This is the overall temperature trend from 1948 through to 2008. Now, what you're seeing here is what we call the deviation of the yearly temperature from the mean, the 1961-1990 normal period, which is a reference period used by the IPCC, the Intergovernmental Panel on Climate Change, which is, of course, the number one authoritative body when we're dealing with climate change. So you can see here, overall statistics for Canada, we can see a steady increase in temperature. Now, that is quite significant because you see long-term climate change that induced naturally is relatively slow, in the order of 20, 30,000 years, in some cases 100,000 years. And the change might be in the order of 2 or 3 degrees. And that, in fact, when we look at global mean temperature, that is enough to cause significant changes to weather and climate and ecosystems and so on and so forth. So the change that we're seeing here for Canada is over a relatively short period, which is very, very significant because, as you know, human society are not able to adapt to significant or rapid changes in climate because it takes a long time to get programs and policies in place. As you know, even right now, we're still debating in Canada whether we should mitigate or adapt to climate change. These processes, policies and programs take a long time. And so when we're looking at a significant change in the climate of an area over a relatively short period of time, that's what becomes very problematic because society is not able to adapt and to mitigate on a fairly rapid basis. Anyway, just to give you then a quick rundown of what's happening in Canada. This is the Great Lakes area. The Great Lakes region, St. Lawrence Great Lakes region, is seeing significant change. And of course, the area which is seeing probably the most dramatic change in climate is the Arctic region. And for obvious reasons, those of you who are informed on climate change, that this area here is seeing significant reduction in ice cover, seeing significant reduction in snow, seeing some increase in precipitation. And of course, you know, right now there's a lot of interest in this area in terms of the Northwest Passage, open up the area for shipping and so on and so forth, and of course for exploration for oil and gas. That area, of course, quite apart from the economic activities that are likely to be realized from climate change in the Arctic, there are some significant environmental changes and changes to the climate, the rest of Canada and North America, which are of really serious concern. So the point is then there is very strong evidence for climate change, and I don't have the time to look elsewhere outside of North America, outside of Canada, but certainly here within Canada, because here in Canada we have, as you can see, a fairly wide range of climate. Canada, even though on the outside we're seen as a cold climate, but within Canada, when you look at the different climatic regions, ranging from the Arctic to the West Coast, the East Coast, to the Prairie regions, the Great Lakes, and so on and so forth, fairly wide range of climatic zones. And we're seeing in all of these zones, for that matter, with the exception, of course, of Atlantic Canada. Atlantic Canada is not seeing the kind of significant changes in climate and precipitation as the rest of Canada, but certainly there is some weak indication of a warming trend in that area. And the same thing for the prairie regions. So what I'd like to look at then is to focus on the different regions of Ontario, but also looking, as I said, on a seasonal basis, how our climate is evolving over the course of the last 40 years. Okay, one of the things that we tend to look at, certainly in terms of climatic indices, we can look at things such as growing degree days, we can look at mean temperatures and so on and so forth, we can look at diurnal temperature range. I'm looking here strictly at the trends in the mean temperature. And as you can see, one of the studies that have been done thus far especially for middle latitude countries, countries such as Canada and much of the United States and parts of Western Europe, is that we're seeing a moderation in winter temperatures, as we'll see later on. And we're seeing a fairly significant increase in temperature or warming trends in the spring. We're not seeing much change in the fall, but certainly our winters are getting milder, our springs are getting milder. And you'll see that certainly here is reflected in the data, certainly for Ontario. Now, I've looked at Haro, which is, Haro of course represents the Lake Erie North Shore area. And as you can see, over the last 40 years, we've seen an increase of roughly 1.5 degrees centigrade in the mean temperature for April. Now, that's very significant. Now, I want you to note also, not only in terms of the temperature increase, but notice this here. This is significant fluctuation. And this is what is very characteristic of our climate. Okay, we talk about volatility. If you are an investor in the Toronto Stock Exchange, you can appreciate the volatility in stock movements on a day-to-day basis. The TSX, of course, the price of your individual commodity goes up and down, but the overall trend, if you invest it in the long term, you can see that the trend is an increasing trend. So in spite of the significant variation from one year to the next, there is a significant increase in trend. This in itself, the volatility is not very good for viticulture. It's not good for agriculture in general. We like to see some variation, but not significant variation. Okay, and similarly for vinyl, which is typical of the Niagara region, we're seeing a fairly significant increase in trend. And again, fairly significant variation from one year to the next. So over the last 40 years, we've seen an increase of roughly 1 degree from the 1970s to roughly 2012. Now, 1 degree is a very significant increase because the average temperature in the month of April is about roughly 4 or 5 degrees centigrade. So 1 degree change in temperature is quite significant. And we'll see the implication of that in terms of heat units when we get into the actual growing season. And the same thing for Prince Edward County. If we were to superimpose all these graphs, you'll see the fluctuation very much the same. Whatever happens in Lake Erie North Shore, whatever happens in Niagara region, Prince Edward County, you'll find that the same weather system affects the entire area. The only difference is there is a difference in terms of the magnitude of the temperature change or precipitation change, as the case may be. Also, one of the things that we tend to look at, which is a very telling index in terms of the potential of an area for certain varieties, is the frost-free days. Now, in delimiting the frost-free days, I use -2 degrees as the last day of a killing frost. That may occur sometime in the latter part of April or early May, and the first day of killing frost in the fall, which again -2 degrees. Now, Environment Canada takes 0 degree as the threshold, and some people might use 1. For viticulture, I think you're likely to have major bud damage at -2, whether it be in the spring or in the fall. 0 degrees, the chances are you may have just moderate damage, nothing at all. So a good way to delimit the frost-free period is to use, in my case here, I've used -2 degrees. And as you can see, the spring frost, this is the first frost-free days. This is the last spring frost. As you can see, the widening here gives us some indication of the length of the frost-free period. And so notice the width between these two lines, the first and last day. In other words, then we're seeing an extension in the number of frost-free days, which bodes well, because as you know, the growing season pretty much ends when you have a killing frost, -2, -3 degrees, because once the canopy is damaged, then that's it. Okay, so this is good. This is good news for the industry in the sense that we're seeing an extension of the frost-free days, which allows us to grow certain varieties, especially some late-season varieties. And this is the same data looking at from the standpoint of vanilla. Again, as I said, if you pay attention to this the graph here, we are seeing some change in the number of frost-free days beginning from the 1970 right down to 2011. Not a very significant, but certainly an increasing trend. And the same thing for Harrow. We're seeing an extension of the frost-free days. And here I'm looking at now the growing degree days, and growing degree days, of course, gives us some indication of the amount of energy available for photosynthesis. Now, most studies, of course, use 10 degrees centigrade as the Winkler index, as one of the standard index used in actually assessing the growing potential of an area. 10 degrees is used because 10 degrees is the base level at which photosynthesis takes place. Not to say that photosynthesis doesn't take place below 10 degrees. In most cases, of course, we're not measuring leaf temperature. Leaf temperature ideally should be the temperature measured in actually determining the potential of an area, but we're measuring air temperature. That's been the conventional way of doing it. Certainly then, as we can see in the case of May, not much happening in, both April and May, but certainly May, more pronounced warming in May. And as I said to you, most of the study is done on Europe, especially Western Europe, beginning in the Champagne region, northern Germany. We're seeing earlier bud bursts in these areas as a result of global warming. And those signs, of course, are certainly evident here in Ontario. Much earlier bud bursts, which to some extent has its advantage, but when you have early bud bursts, the chances are, of course, you might have maturity of the fruit in a period when temperatures can be quite high, and that's another matter we need to look at later on. Not much of a change for Lake Erie North Shore in May, but certainly a very minor change in April. Prince Edward County, some significant change, but again, I want you to note this is one of the things that characteristic of middle latitude climate. No two vintages, as you know, are the same. Each year is subjected to a different set of climatic conditions, and therefore you tend to see some variation in vintage reflected in that. Grey County. I look at Grey County. This is the area we talk about, Georgian Bay area. Notice this here. Very wide, very wide changes in terms of growing degree days in the month of May, and certainly in the month of April. So this is something that is of concern, obviously, to grape growers, is the volatility from one year to the next. You would think that being close to water, that you see some moderation and some stabilization of the temperature, but you're looking at an area where you have warm fronts, cold fronts, and so on and so forth, where you have the jet stream may move further south or stay further north, all of which then contributes to the variation. But by nature, spring weather tends to be very highly variable. Spring is characteristic of the weather, which you have cool fronts, warm fronts, and from one year to the next and one day to the next. Is the summer getting warmer? I looked at the heat units. The mean temperature of the growing season. The mean temperature of the growing season, we take the average temperature for each month, April, May, June, July, August, September, and October, and we find the mean temperature. It is a general climatic index, which is often used to give you some indication of the potential of some varieties, okay, to thrive in that area, to reach maturity. In the Niagara region, as you can see, we have a mean temperature of roughly 15.7 degrees, which corresponds to the Burgundy area. Okay, and this is, of course, the temperature taken at Vineland. I might add one thing that we need to take note of is that when we're doing regional analysis, when looking for long-term trend, one station in a region might be adequate. Okay, because we're not so much looking at the magnitude of the change from one year to the next, but we're looking for trends. But when you're looking to determine microclimate difference or mesoclimate difference within an area of very complex topography, then you need to pay attention to the individual climatic station, the data for individual climatic station, because the climate in one area will be significantly different from the climate in another area. But in terms of the larger picture, one station is quite adequate. And so, as you can see, what is happening here, I know we we're considered to be a cool climate region. But a cool climate region would be an area where the temperature, for the most part, is roughly, the average mean growing season, roughly between 13 and 15 degrees centigrade. That's the ideal cool climate region, okay? We are in the intermediate zone, okay, between the cool and a warm area. And I want you to note here is that over the years, okay, even though I said to you we're seeing significant fluctuation from one year to the next, but what I want to show you is that we're actually moving from a cooler area into, and in some cases, into the warm zone, okay? And of course, some of those years might be considered vintage years, very good wine produced during these years because unusually high number of heat units, I don't know. But certainly, we're evolving. We're not, and this is something that you have to understand about climate change. Okay, and this is what makes it, it's like a shooting target. Okay, things are changing. Whatever we use today in terms of temperature and precipitation and so on and so forth, those are not the same. This is why the average, when you're using statistics such as average is a useless statistic. It's only used for a comparative reason, but it's not a good statistic for when you're looking at the potential of an area. You want to look at extremes, how low, how high, how low, and so on and so forth. So this is a typical example of an extreme, very low and very high, okay? So within the Niagara region, one can see that your mean temperature growing season can plummet down to 14 degrees, and it can go as high as 17 plus, okay? And somewhere in there then is your average, okay? But I want you to pay attention that the area is actually evolving, okay? It's evolving into something a little bit warmer, okay? And that is certainly attributed to climate change. We look at Lake Erie North Shore. Lake Erie North Shore is certainly in the intermediate zone, okay? It's not even in the cool zone. This, of course, is a fairly warm area. It's the most southern location in Canada. Pelee Island is actually the most southern location in Canada. And of course, this is taken from Harrow, which is not very far away. So that area, certainly their growing season starts fairly early, and we know that they enjoy much higher temperatures, not only because of sunshine, but also the fact that Lake Erie, of course, loses its ice cover fairly early, and it warms up quite quickly, and it does make a big difference also in the fall in terms of retention of heat. And so, but this area then I want to show you then that it is moving from an intermediate and in some years into the warm zone. We would like to think that this area here would be ideal for red wine production, as we'll see later on when we look at the heat units. And similarly, now, Prince Edward County, this area here certainly fits the classic example of a cool climate, but some years gets into the intermediate zone, okay? We'll look at the heat units of these areas and it'll give us some indication, not altogether, but some indication of the potential of some varieties. Now, total heat units, as we'll see later on, is not the best indication, but the distribution is more important. So, I tossed this diagram here. It looks pretty busy, but the reason for this here, I want you to show that these three regions, they're pretty much in sync in terms of what happens each year, okay? Very much in sync. In other words, when the temperature is high in Lake Erie North Shore, it's high in the Niagara region, and also high for the most part in Prince Edward County. And that goes to show then that, as I said, the same large-scale synoptic conditions, weather conditions, tend to affect much of the area, with the exception that, as I said, the local topography will modify temperature and therefore gives rise to some unique conditions. Okay, so I decided to look at the heat units because this gives us some indication of some of the varieties that we can grow successfully in the growing season. I want you to remember that because when we assess an area for certain varieties, there are two separate conditions that we can look at. We can look at the growing season heat requirements, but we need to pay attention, certainly in our climate, to the winter temperatures because you can grow most of these varieties in this area for the most part. However, the question is, will some of them survive the winter? And we know that to some extent is probably one of the #1 limiting factor in terms of the success of viticulture in Canada as a whole. So we're looking at the the mean growing season for Niagara here. This is the Niagara area. And over the years, then, we've seen an increase of roughly 200 growing degree days from 1970 to 2012. That is quite significant, okay? Very significant. So we are in, this is, and given the heat requirements for these varieties, these are the varieties that are likely to do well. But I want you to note that not in every year. Look at the variation, okay? So this is one of the concerns that we have. And this is something that we need to pay attention to when we assess an area for the suitability of an area for certain varieties, that we're not only just paying attention to the total heatiness, but we want to look at how the climate actually varies from one year to the next. So in some years, these varieties do well, okay? But in some years, as you can see, they're way below, the heatiness way below the threshold necessary for full ripening potential. These varieties are likely to do well. The heatiness will be met practically every year. But when we come to varieties such as Cabernet Sauvignon Blanc, of course, this is a variety we grow in the Niagara region, but it's one of the varieties very, very susceptible to winter injury because it's not a very cold hardy variety. So I want you to show you that this area here, this is region 1, this is region 2, this is region 3 in the Winkler classification, and that we're seeing some evolution of the climate and therefore some likelihood of the effect on certain varieties already established in the area. And similarly for Lake Erie North Shore, Lake Erie North Shore sits directly in region 2, okay? Not a lot in region 1, so it's not the very, very cool area we might think it is, okay? But certainly it sits in region 2 and in some years in region 3. Region 3, of course, Syrah. We do have some Syrah growing in the Niagara region and certainly in Lake Erie North Shore. This is a variety that requires fairly high heat requirements, similarly Petit Verdot and Grenache, but they're not very winter hardy. You really have to baby them. You have to set the wind machines right over the vineyard and actually cover them. So there is a problem there to some extent. In Prince Edward County, this is one area. Again, this area is showing some evolution, and these are some of the varieties that are likely to do well in a cool climate area. Okay, certainly Cabernet Sauvignon will not do well because the heat units are quite low in this area here, apart from the occasional year in which it goes up to 1,500. But for the most part, most of the heat units are below 1,300. So this is certainly a cool climate area from that standpoint. It has a climate which is ideal for some of the cool climate varieties such as Pinot Noir, Chardonnay, Riesling, and so on and so forth, and even Gewürztraminer and Sauvignon Blanc. But varieties such as Sauvignon Blanc, Pinot Grigio, or Pinot Gris, these are not cold hardy varieties. But I'm just, as I said, just talking about the potential during the growing season. The winter is another matter altogether. Grey County, very cool area, certainly a region 1. So if in years, this area is already experimenting with some varieties such as Riesling, and they have a number of hybrids, Riesling and Pinot Noir, but certainly it's not an area that will do very well for reds, but certainly can do very well for some of the whites. Certainly Riesling will do very well. Chardonnay is a very versatile variety because Chardonnay grows well in a warm climate and a cool climate. And similarly with Riesling to some extent. But Riesling is in fact more of a cool climate variety than anything else. Cab Franc certainly has a wide range of climate, from cool to very warm, can thrive in that. So again, all the trends are the same, an increasing but fluctuating trend. And I did it for Durham County since there is some interest in growing grapes in that area. This climate here is very similar to Prince Edward County, with heat units under 1,200 growing degree days. So I don't see that area emerging as a warm climate area in quite a while. But as you know, as the industry expands into these areas, chances are we'll have much greater diversity of wine style, especially as the climate warms up in some areas, and we're seeing some slowdown in the warming trend in these areas such as Prince Edward County and Durham County. And just want to show you the trends. They're all the same for these different wine regions. So if you're looking at overall trend, any one region will give you some indication of the long-term direction of the climate, very much in sync. I'll skip that there. This is I tossed in this graph here just for the Niagara region. I didn't look at the other areas. I looked at the July temperature because very often July, of course, in the middle altitude region is the warmest month, and it gives us some indication of the sort of varieties that are likely to thrive in that area. And certainly from the standpoint of the index and the classification, it's certainly in the region 2 based on the mean July temperature. Mean July temperature for this area is roughly about 21.3 degrees centigrade. But as you can see, as I said, never use the mean because nothing stays on the mean there, always below and above the mean. And we looked at the number of hot days, 30 degrees. This threshold here, some studies use 35. Why 30 degrees? Because at 30 degrees you tend to have some significant reduction in photosynthesis. And of course you can have a complete shutdown of the vine if the vine is not able to access moisture. But we're seeing then, as you can see, an increasing in the number of extreme temperatures above 30 degrees. This is a fact, and this is likely to happen with climate change, more extreme days with temperatures above 30. Okay, so what I'd like to look at next is the temperature trends, rather the precipitation before we go to the fall. This is the April to October total precipitation. This is the growing season precipitation. Again, a lot of fluctuation and no real significant trend. In fact, it's a downward trend. We'll look at this here when we look at the forecast for the next 40 years. We'll see that precipitation increases slightly by 9%. But one of our concerns is not so much the overall total growing season precipitation, but what actually happens in the month of September and October, because this is the period, this is the ripening and harvest period. And one of the things about the precipitation in Ontario is that we tend to have a very, very high precipitation in the month of September. In fact, it peaks in September and there's a slight decline in October, then it goes back up in November and December. March, of course, relatively dry, but September is a problematic month for us. And problematic because in some cases where we have early season varieties such as Pinot Noir and Chardonnay, heavy precipitation, especially last year, you probably note, can cause major problems. And so we want to know whether the precipitation in the fall, because it's a crucial time for the harvest, a crucial time for grape, September, October, veraison. Sometimes veraison may start in August in some cases, the latter part of August, but certainly the ripening and harvest period in September and October. And for early season varieties, when you have high precipitation, obviously you can certainly compromise the crops. And we're not seeing any trend at all here. The trend is a very, very weak trend. It's not increasing but decreasing. But certainly it's a period of very high precipitation. And the same thing for Lake Erie North Shore in terms of the overall trend. Now, I'm noticing here, and this is somewhat unusual for Prince Edward County, I'm seeing an increase in the overall precipitation for Prince Edward County, and certainly in the month of September and October. And I can't account for that. I'm not certain why the precipitation would increase in these two time periods, April, October, and a mild increase in the month of September, October. But certainly then the trend is an increasing trend. In Grey County, we're seeing September, October, no real trend, and a slight weakening trend for the overall precipitation during the growing season. Now, One thing that, as I said, we need to take note of, and I can't show you month by month, otherwise we'll be here for a couple hours. So we have to choose a time period. And as I said, I don't like using an index which looks at simply the entire growing season, because really to truly understand what's happening, you need to look at it on a monthly basis. But nonetheless, when we try to make comparisons with other areas, not only in Canada but other regions of the world, some of the indexes are fairly standard index, so we try to adhere to that to some extent. But really, for more insightful analysis, you need to actually analyze the information on a much more detailed basis. And this is a trend for Durham County, and I'm not going to spend too much time on that. This is a temperature trend for three seasons: August, September, October. No real changes. I say the fall. We're not seeing really any great movements in the climate in the fall. We might see some slight change in the growing degree days in the month of September, but for the most part, we're not seeing a fall getting warmer. Pretty flat, relatively. Same thing for Lake Erie North Shore. Not much for Prince Edward County. So the fall is not, we really would love to have a nice, warm, dry fall, because that certainly would allow some of the late season varieties to reach their full ripening potential. Now, this is some statistics from the Grape Growers Association looking at Brix level. Now, we have to interpret this very, very cautiously, because over the years we're seeing Brix level, of course, is a sugar level for those of you. We measure the quality of the grape by the amount of sugar it has at harvest, and so it can actually influence the price of the grape and certainly the quality of the wine. And over the years, you've seen a significant change in the Brix level for these 4 key varieties. However, as we know, in viticulture, we have the large climatic influence, temperature and sunshine and so on and so forth. But sometimes we can actually have significant influence on canopy by canopy management, crop load, and so on and so forth. So we have to be careful with Brix level here. We cannot assume necessarily that this is all due to climate change, because viticulture practices can certainly make a big difference in the quality of the grape at harvest. Nonetheless, certainly we're seeing a trend here, certainly an increasing trend in the Brix level for these key varieties from 1985 to roughly 2010. I don't have the statistics for the most recent years. So that bodes well, if that's the case. And I looked at heat units during the growing season. Of course, the growing degree days, we can look at temperature, we can look at growing degree days. The trend, not very strong trend, but a weak trend for the most part in the 3 critical months, August, September, and October. And same thing for Lake Erie North Shore, and of course Prince Edward County. And okay, so that's heat units. As I mentioned also, one of the things about climate change is that we're seeing more extreme events. We can see more extreme temperatures, high temperatures, maximum temperatures. We can see more extreme precipitation events. So I wanted to see whether we're seeing an evolution in the occurrence of more extreme precipitation events. First of all, I'll start by looking at the number of days with rain, 1 millimeter of rainfall. And here we're seeing no real, it's a slight downward trend, but really no significant change in the number of events with rainfall. This can assume this is all rain here, because this is the growing season from April to the end of October. If you have snow, then we're in trouble. So this is all rainfall. Overall, 1 millimeter of rain is not problematic, certainly for the quality of the grape. It can cause some fungal diseases if things are not taken in hand. But what I was more interested in is the occurrence of extreme precipitation, 10 millimeters or more. This is a threshold I use. And here we're seeing, to some extent, sort of a downward trend in the number of extreme rain events. Now, as I said, what is of concern to us is not so much the amount of precipitation, but when it occurs. And certainly in the month of September, if we have high levels of precipitation, accompanied by relatively cool temperatures, we can have some problems. Certainly for early season varieties. For late season varieties, it may not be problematic. But one of the good things here is that we are seeing some significant downward trend in the number of extreme events with 10 and more millimeters of precipitation. Okay, the other thing I looked at is the diurnal temperature range. The diurnal, the difference between the maximum temperature of the day and the minimum temperature of the day. And the range, the difference between these two is the range. The difference between the maximum, the highest temperature of the day, and the lowest temperature of the day. Typically, maximum temperature will occur around 2 or 3 o'clock during the day, and minimum temperature typically occurs just before sunrise. The lowest temperature actually is in the early morning hours just before sunrise. Now, the diurnal range, what's the importance of the diurnal temperature range? Well, in a lot of studies, especially during the ripening period, okay, during the ripening period, month of September, October for us, February, March in the southern hemisphere, the diurnal range is very important because during the day, if you have relatively high maximum temperatures, the chances are you have good photosynthesis and good Brix level, sugar level builds up. And at night, if you have relatively low temperatures, I said relatively low, then you're able to preserve the acidity. So we have good Brix level during the day and good acidity level. So the range is very crucial. And the range is actually even crucial, very crucial, especially for what we call warm climate regions, parts of California. And we're seeing some huge diurnal range, for example, in southern parts of the Okanagan region. Because the Okanagan region is a dry region, so very warm temperatures at night. And if you don't have low temperatures during the day, during the evening hours, then you have, in fact, very, very high sugar levels and very low acidity. You have very flabby wines. So the diurnal range is very crucial, and certainly the diurnal range for us, say in the Niagara region, is roughly about 10 degrees centigrade. In other words, on any one day during the month of September, October, certainly in the month of September, we're seeing a range of roughly 10 degrees. Okay. Now, there are some number of studies that looked at the importance of the diurnal range. Some people believe that the smaller the range in the cool climate region, the better it is, because then it allows the grape to actually experience not only physiological ripening during the day, but also at night. So you don't want the temperatures to fall too low during the night. However, if your daytime maximum temperature is very high, then ideally your nighttime minimum temperature should be relatively low. So the range depends on the actual climate of the area. Now, because we're relatively close to the lake in some places, our diurnal range is relatively small because the lake tends to keep minimum temperatures quite high. But away from the lake, we're seeing very large diurnal temperature range, very high during the day and very cold at night. That in itself might be useful for wine quality, but when you have very large diurnal temperature range, especially in the latter part of the fall and in the early part of spring, that is an area which has a high risk of freeze injury, because normally frost is associated with a very high maximum temperature, clear skies, sunshine during the day, and clear skies and strong radiational cooling at night, and therefore you have very low temperatures. So the range itself, a large diurnal range, while it may be beneficial for the ripening process, it actually does lead to much higher levels of incidence of especially radiation frost in the early spring or late spring, and certainly in the fall. Is the winter getting warmer? I'll skip this. This is just the average minimum temperature for the Niagara region and Lake Erie North Shore. I chose these two stations and look at the January temperature, because January, as you know, is the coldest month for the most part in the middle latitude region. And we're looking at the minimum temperature, and it's again strong fluctuation trend, but certainly it's increasing. So we're seeing an increase in the average minimum temperature in the order of roughly 2 degrees, and that's very significant. So is our winter getting warmer? It's getting warmer, relatively speaking, okay? In other words, when it's 15 degrees, minus 15 degrees, that's cold, and minus 12 degrees is still cold, so it's just relative, okay? But I want you to look at Prince Edward County, because here the Niagara region, Lake Erie North Shore, and so on and so forth. Sorry, this is Lake Erie North Shore. The overall minimum temperature is actually showing signs of increasing. So there is some moderation, certainly in the winter. I looked at this, of course, for Prince Edward County, and as I said, it's all relative. Even though their minimum temperature is increasing, you still have the average minimum. Remember, this is not the extreme. This is just the average, which means that somewhere in there embedded is the extreme, right? So the average, even with an average, you have minus 18, which is minus 16. So that's still very cold. But nonetheless, who knows? In about 20 or 30 years, this area here would certainly emerge as a much milder area. But right now, it's still relatively cold. And again, the sink, all of them in the same sink, so the trends are very much the same. One thing that I noticed about our weather in the last 10 years, okay, certainly in the last 10 years, this is not characteristic of the data going back to the 80s, 70s, and 60s, but certainly in the last 10 years, this is what we're seeing. This is what we're seeing here. Very, very significant changes in the day-to-day weather within the Ontario. Okay, and this is, I know Kevin has done a lot of work out there. He's very close to the vine, but this is of concern to us. It's not only that the winters are getting milder, but we're seeing this seesaw. We're seeing cold spells followed by warm spells. Now, when the vines are in full dormancy in the month of latter part of December and January, and probably the first couple of weeks of February, possibly this kind of seesaw in temperature may not be very problematic. But we know that these vines go through their dormancy period, and for some of the early season varieties, by the end of February, that dormancy is completed. And so any type of moderation in the temperature could lead to blood swell, and followed by a cold snap, and you have a problem. So my point is this, that even though we still are seeing some occurrence of extreme minimum temperatures in the order of minus 25 and lower in some cases for Prince Edward County, and we're seeing a moderation. We're seeing less frequent, as we'll see, less frequent damaging temperatures. But what I think we'll be seeing is another kind of winter risk. And this winter risk, it will not be associated necessarily with very, very low temperatures. In fact, we could see more damage at higher minimum temperatures. Okay, at higher minimum temperatures, primarily because of the volatility that we're seeing, warm spells followed by cold spells. And so I looked at two temperature thresholds, minus 15. And again, it's the trend here is a downward trend. But again, I want to say this here, very, very high degree of volatility. Okay. No 2 years are the same. The trend is good as far as minus 15 is concerned, downward trend, but the area that is of concern to us here is minus 20 and lower, because most of the damage that we see with respect to the primary bud is the fruiting bud. The threshold of damage, of course, varies with these varieties. Pinot Noir might be minus 20, 21. Sauvignon Blanc might be minus 18, minus 19. Cab Franc might be minus 21, some minus 23. Chardonnay is a little bit hardier, and so on and so forth. But one thing also, that the damaging threshold is, even though we look at it as a fixed temperature, the phenology of the vine is changing all the time, and therefore the damaging threshold temperature is also changing. But one of the good things about extreme occurrence of minimum temperature is that those events we're seeing a significant decline. Okay, we're not seeing as many events with damaging temperature below -20 and lower. Certainly, that's the case for Lake Erie North Shore, and that's the case for Niagara region. Prince Edward County still continues to have very low minimum temperature, primarily because of its location. Even though it's sitting with both its feet in Lake Ontario doesn't have the kind of moderation that the Niagara region gets, because the damaging temperatures are coming out of the north. These are Arctic air masses, cold and dry at -35 degrees centigrade. And so before they cross Lake Ontario, they run smack into Lake Erie North Shore, Prince Edward County. And by the time they cross the Lake Ontario, and nowadays, of course, we have more open water, our temperature would have moderated by as much as 10 degrees. So on reaching the south shore of Lake Ontario, the Niagara region, that's our actual defense, Lake Ontario, the open waters of Lake Ontario. With climate change, we're seeing then more and more open water in the Great Lakes. Lake Huron, actually, we're seeing more open water in Lake Huron. This is why I think, for example, Huron County, the eastern shore of Lake Huron, that area has a lot of potential in the next 10, 15, 20 years, with, if of course, we continue to see the same trend in terms of ice cover. The same thing for Lake Michigan. Lake Michigan also, we're seeing significant reduction in ice cover. Lake Superior still has quite a bit of ice cover. The Georgian Bay area, unfortunately, is a great place. It does get some moderation from Lake Huron, but Georgian Bay itself actually ices up in the winter. It's an area that's still relatively shallow, because the depth of the lake has a lot to do with the freezing, the extent of freezing. This is why Lake Erie, in the western portion of Lake Erie, which is the shallowest part of the lake, no more than 8 meters deep, is the first area to freeze up, and it's the first area, of course, because of its shallow depth, to actually thaw out in the spring. So we're seeing less and less lake ice cover in the lakes, which bodes well for most of these regions. This is why in the expansion of the industry, we still have to stick pretty close to the lake, especially downwind from the lake, downwind. Lake Erie, Prince Edward County is upwind, okay? We are downwind, fortunately, of Lake Ontario. So downwind is where we need to go. So location is still very important. It's like Tim Hortons. You have to do your location analysis. I won't spend too much time on this, but one of the things about moderating winter is the likely impact on the ice wine industry. And the good thing is, I think for us, even though we're seeing a significant reduction in what we call picking days, where the temperature drops to -8 and below. As you know, for ice wine, the ideal picking temperature is somewhere in the vicinity of 8 to 12 degrees centigrade. And you know, this year -8 didn't materialize well into February? Latter part of January. And so this is what we're seeing. The overall trend is that we're seeing a significant reduction in the number of picking days. Now, certainly in Prince Edward County, those temperatures came quite early, but for Niagara and Lake Erie North Shore, quite late. So I see that perhaps in years to come, we'll see a shift to some extent in where certain varieties are likely to thrive on a more consistent basis. Because as you know, in the wine industry, as I said, first impression is the most important impression you can make. Because when you produce your first wine, it better be good, okay? Because no one's going to go back there to try bad wine second time. There's so much out there. So when you come out with your first wine, it has to be a good wine. And so consistency is very important in the industry. Consistency in good quality, right? Maintaining. Going back to the ice wine industry, very quickly, there is, if you will, a certain window of opportunity for picking ice wine. We know that, for the most part, very rarely do we get -8 degrees before the end of December. More than likely, the latter part of December, the first, maybe the last 10 days of December, the last week of December, you tend to have some days with temperatures drop to -8. And so this is the window of opportunity where you have more than 50% chance of having temperatures dropping below -8 degrees. Once you get beyond that, once you get beyond the latter part of January into February, forget it. Okay, you might as well harvest it for a late harvest wine. So that's what we're seeing in terms of the window of opportunity. And looking at the number of days with events -8 and below, as you can see in December, relatively low number of days, but a somewhat declining trend. The critical time, of course, is January, and here we're seeing, again, significant variation, but again, an overall weak declining trend. My concern is this, is that it's not that we are not seeing -8 and lower in the winter, but -8 and lower is occurring a bit later. And so that could be a problem for the industry to some extent, in the sense that the longer the grape stays on the vine, the greater the chance that you'll have rot, especially if it's mild temperature, and greater chance of losing it from pests and so on and so forth. So perhaps in years to come, if these areas that are currently affected by abnormally warm temperatures, we have to shift the area for certainly ice wine production. Fortunately, this segment of the industry is not huge, but nonetheless, it has garnered a lot of international attention for Canada. It's Canada, everywhere you go and you speak of ice wine, Canadian ice wine is still seen as very, very high in quality, very consistent in quality, and so we've garnered a significant reputation for ice wine, and let's hope we can keep that. Now, this is not just Ontario. Of course, we know that we have much colder areas where ice wine can be produced much more consistently, certainly in Quebec, where temperatures are still relatively colder. And those are the same sort of trends that we see for Lake Erie North Shore. Lake Erie North Shore is not a big producer. I think more than 60 to 70% of most ice wine produced in Canada, for that matter, is actually produced in the Niagara region. It's still the #1 producer. So that is of concern for us in the Niagara region. Small batches of ice wine produced in Lake Erie North Shore and Prince Edward County, and to some extent in Okanagan. But Niagara region is still the #1 producer of ice wine. So that's the trend for picking days. We've seen a significant reduction in the number of picking days from 1977 in the order of roughly 15 days, right? But as I said, it's not just the days. We're not just concerned with the days. It's when the temperature occurs. That's where we need to have more focus or analysis. When do we see the opportunities for picking days? Are those, and the opportunity for picking days, of course, is in the latter part of December, early January, possibly end of January. Beyond that becomes problematic. Okay, so in concluding, what I'd like to look at is we're looking at these time series graph for the last 40 years, okay? And as you know, in forecasting, sometimes we look to the past to give us a clue of the future, okay? It's not very good to look back, it's always good to look forward. So, because the industry is evolving, and we want to know in which direction the industry is moving. And how can we then determine the direction in which the industry is moving? Well, we have some models that can help us, general circulation models, not good-looking male and female models, but general circulation models. These are models that give us some, and you people are trying to make a joke, you not even. Anyway, general circulation models are ones used here. And so what we've done, and this is where Dr. Adam Fennick was with the Ministry of Environment in their climate adaptation group. He's now Director of Climate Change at University of Prince Edward Island. We've done some preliminary studies on what we call statistical downscaling. We take the general circulation models, and there are a number of them, as many as 30 of them, and we've selected four of these general circulation models, And we've taken a number of scenarios described by the Intergovernmental Panel on Climate Change. We took 3 scenarios. The so-called worst-case scenarios with respect to climate change, in which we do nothing. In other words, business as usual. We continue to emit high levels of pollution, population grows, and high levels of consumption and so forth. That's the worst case. Then we have the medium case, where some technology, sustainable technology, introduced reduction in population and so on and so forth. And then we have what we call probably the best case scenario, in which we take drastic action, we do mitigation, adaptation, and so on and so forth. And so what we've done then is to use those general circulation models and the different scenarios, and using the data for I think 6 climatic stations in selected wine regions, we want to see how the climate is likely to evolve given those scenarios over the next at least 30, 40 years, well into the 2050s. And so what we've done, we looked at the mean temperature. We want to determine the mean annual temperature. And for the area, we use Vineland, Thornbury, Simcoe. These are all areas within the established emerging wine regions. So what we're seeing then, by 2050, we'll see an increase in the mean annual temperature of roughly 3.1 degrees centigrade. Okay, the mean right now is roughly 8.2, 8.3 degrees. Now, 3.1 degrees increase is quite significant. Okay, 1 degree increase in temperature, especially during the growing season, translates to 214 growing degree days. Okay, a 3 degree increase in temperature, if things were to continue. Okay, I might add also, what we did here was what we call an ensemble. We took the median value, the average values from these different forecasts. So there are some of the forecasts give us a much higher, some give us a much lower. So we've taken the median or the average value. So we're seeing then an increase in order of, in some cases, 3.2 degrees, and as low as, in this case here, 2.8 degrees. Okay. So is that significant or not? It is quite significant. So what we could see a totally different climate in the next 30, 40 years if the conditions were to continue. And I said to you, if you were to see an increase in the order of 3 degrees centigrade in the growing season, right now for the Niagara region, the average temperature is about 15.7 degrees centigrade. If you go up to 18 point something degrees, we're putting our climatic region equivalent to that in Pennsylvania, because Pennsylvania mean annual temperature is roughly about 18 degrees. Okay, so, and that's the situation we'll see if trends were to continue within Ontario. So we haven't looked at all the indices, because this is just a preliminary data, and this is, of course, as I said, looking at a number of. We look at 4 different models, and this is what we call the ensemble, the average temperature based on the projection for these different models. And similarly for the minimum temperature, we were expecting to see a much higher increase in minimum temperature, because minimum temperature is the one that's increasing on a significant basis worldwide. In other words, nighttime temperatures are getting warmer. That seemed to be the trend. And it is believed that the reason for that is probably high levels of moisture content. In other words, the higher the moisture content of the air, the slower the cooling by radiation, and therefore the higher the temperature. We're not seeing a significant reduction or increase in minimum temperature, but we're seeing a significant increase in maximum temperature. And so the forecast then for this area for the next, well, in this case, roughly 30, 40 years, is one in which we'll continue to see warming temperatures unless something is done drastically. And even if we do take drastic change in terms of mitigation, development of renewable energy technology and various ways to reduce CO2 levels and various greenhouse gas, because of the longevity of many of these gases, the chances are it'll be another 40 to 50 years before we see a significant reduction in temperature. So it seems right now, as we debate the issue on a global scale, and certainly here in Canada, and all the problems we have with XL, Keystone XL, and so on and so forth, it is likely, we will likely see a significant warming trend that will continue for some years to come. And so we are seeing then a change in the climate, which is not stable. It's not a stable situation. We're seeing an evolution. And that evolution, unfortunately, is occurring quite rapidly, much more so than we're able to deal with it by effective policies, whether it be by way of mitigation or adaptation. So it's incumbent on us to look to see how we can, if you will, make some strategic moves for the industry, both in terms of where we should plant, because I will say to you right now, in parts of Australia, and certainly in Australia, the big corporations are already looking at moving up to higher elevations because the temperature is getting warmer. Even in Spain, because Spain is a very warm country, and they're looking at moving into different areas where the climate is moderate. And so in the long term, we still have some flexibility in Canada because of the diversity of climates, and certainly within the Great Lakes, we still have some opportunity to move into areas that are right now considered to be climatically marginal, especially in terms of heat units and extreme minimum temperatures in the winter, but areas that are likely to evolve in the next 30 years to be areas of very active grape production. So don't want to make us feel too complacent because we need to take some fairly dramatic changes in terms of what we do and where we go in the next 30, 40 years.
Thank you, Tony. It's been a great presentation. At this point, are there any questions? And then what I'll get you to do, Tony, is to repeat the questions. So for those that are listening on the web, are there any questions? People here? I have one. The one I will throw at you, and it's an interesting comment you made about extremely high temperatures and that the fact that photosynthetic activity shuts down. So should we be deducting those days that exceed the levels from our growing degree day accumulation if the plants are no longer accumulating?
Yeah.
And then maybe have a better reflection of the true growing degree days
Good question.
that are actually happening?
Yeah, because that's one of the things that there's a tendency to actually estimate the heatiness if you do not use a threshold. Now, some people, Gladstone, one of the very famous viticulturists, use 19 degrees as a cutoff point because beyond that, photosynthesis tend to decline. In fact, the optimum temperature photosynthesis is about 22, 23 degrees centigrade. Some people I've used a cutoff point of 25, okay, and therefore it's safe. It's within that range, but certainly if you do not use a cutoff, then you have high number of heat units, and it gives him the impression that, well, this is a great area. But something that we've noticed, and I'd like to maybe be dealt with in another presentation, is to actually look at the distribution of the heat units, because total is somewhat misleading. The distribution of the heat units during the growing season is probably far more informative about the climate than the total number of heat units.
And then the corollary question I've got to go with it is, do you think that as temperatures rise, we know that water demands will become greater? So will precipitation and available water for vineyard production become even more a dominant factor as a result of the temperature rise?
We're seeing that not on a consistent basis, but from some years, from one year to the next, we're seeing significant increase in temperature reduction, precipitation. One of the good things, however, is that in areas much drier than Ontario, they've managed to have very successful viticulture, certainly in California, using very sophisticated drip irrigation system. And I think some of our growers already have embarked on that technology. But I think many of our growers are still a little bit reluctant because it's a very huge investment in infrastructure. And as you know, within the Niagara region right now, we still have fairly adequate amount of precipitation, but if you look at the total, it's somewhat misleading. We need to look, because very often much of that precipitation actually comes in early spring, And then we have almost drought-like conditions in the month of July, August. And then we have another deluge in September. And of course, October, when it's usually all over, then you tend to have the really nice, what we call the Indian summer, right? Some cases it's good for some of the late season varieties, but for some varieties, it's Pinot Noir and Chardonnay and Merlot, it's not needed at that point in time.
Well, I think you've done a great job of attempting to simplify a rather complicated interaction of a whole bunch of different factors that are coming into play. With that, Tony, I would like to say thank you on behalf of COVI. We have a small gift for you as well, and we really appreciate it. Thank you very much.
Thank you.
And as a final note to everyone here, the next presentation will be next Wednesday by Dr. Ronald Jackson. He's a wine writer and author. He's also a COVI fellow, and he's going to be talking about wine language and the insight into the mind of a taster. So how do they come up with these wonderful descriptors and then put them in print so that everybody else can understand it? Hopefully he'll address that. So thank you for coming, and see you next week.